Hello and welcome to today's lecture video. This is the lecture we are going to discuss insulin. The pancreas is addition to its digestive function secretes two important hormones, insulin and glucagon, that are crucial for normal regulation of glucose, lipid and protein metabolism. The pancreas is composed of two major types of tissue, the acini and the islets of Langerhans. The acini secrete digestive juice and the islets of Langerhans secrete insulin and glucagon. Islets of Langerhans has three types of cell: the alpha cells, the beta cells, and the delta cells. Beta cells of the pancreas secrete insulin. Alpha cell secretes glucagon, and delta cell secretes somatostatin and gastrin. Now, the insulin is a peptide hormone which synthesized by the cell machinery for protein synthesis, which starts from translation of mRNA of insulin by the ribosome attached to the endoplasmic reticulum to form pre-pro-insulin. This is a pre-pro-insulin. Endoplasmic reticulum cleaves the original pre-pro-insulin to create proinsulin, which is a single chain peptide that is composed of peptide chain A. This is A, this is B, and C, which is called C peptide. Here, A is the carboxyl terminal and B is the amino terminal. Now, the majority of the proinsulin is further broken down in the Golgi apparatus to become insulin, which is made up of A chain and B chain. They are joined together by disulfide bonds. Connected the C peptide. In endoplasmic reticulum, the C peptide of the proinsulin is excited by the endopeptidase to form mature insulin. Through radioimmunoassay, C peptide level can be measured in diabetic patients who are receiving insulin to see how much of their natural insulin is still being produced. C peptide levels are typically significantly reduced in type 1 diabetes mellitus. There is the diagram of the insulin. We can see the structure of the insulin. There are total 51 amino acid, 51 amino acids in a chain, and both chain together. A chain contain 21 amino acids and B chain contain 30 amino acids. The A chain is linked with the B chain. Two disulfide bonds at A7 and B7 and A20 and B19. The A chain has additional intrachain disulfide bond between position A6 and A11. Now, how insulin secretion occurs? Upon entering the cells through the GLUT2, what is GLUT is glucose transporter. There are multiple glucose transporters. We'll discuss them later. Glucose enters through the glucose transporter 2 and phosphorylated by the enzyme glucokinase to become glucose 6 phosphate. This is the rate limiting step of glucose metabolism. It acts as the primary mechanism of insulin sensing and adjusting the amount of insulin is to be secreted in blood. Now the glucose 6 phosphate is then oxidized to produce ATP. Increased level of ATP in the cell causes depolarization of potassium channel and it closes the potassium channel. This depolarization causes the opening of the calcium channel and calcium influx into the cell. So calcium increases within the cell. This increased calcium moves the insulin containing follicle to the cell membrane and insulin is secreted from the cells through exocytosis. Now, what causes insulin secretion? Mainly, three factors increase insulin secretion. They are glucose, amino acids, and fatty acids. Glucose is the main stimulator. Some amino acids and some fatty acids also increase insulin secretion. And there are some inhibitors of insulin secretion. One of them is epinephrine. Others are glucagon, growth hormone, catecholamines. On the mechanism of insulin action. To start function, insulin first attaches to the insulin receptors. Now, insulin receptors are four subunits, 2 alpha and 2, 2 beta. Alpha subunits are outside the cell membrane and beta subunit attach the cell membrane. When insulin binds to the alpha subunit on the receptor, it causes autophosphorylation of the beta subunit receptor. In turns, it induces tyrosine kinase activity. The receptor tyrosine kinase activity begins a cascade of cell phosphorylation that increase the activity of the enzymes, including insulin receptor substrates that mediate effects on the glucose by moving the glucose transporter into the cell membrane. Previously, we discussed that there are multiple glucose transporters. One of them is GLUT2, which increase glucose entry into the cell. This has also effect on fat and protein metabolism. So the ultimate function is glycogen synthesis and reduce blood glucose level.